Visualizing uncertainty is tricky, but it's part of our basic ethical obligation as visualization developers to present our data as faithfully and factually as possible. It's a way of surfacing otherwise hidden data that might affect our reasoning and decision-making processes. In this lecture, I'm going to further explore some additional ethical questions you might want to raise while you're considering how to develop your visualization solution. That is, what do we need to think about in addition to the tasks, the data, and the visual channels that we're using to make sure our data is doing what we need it to do? Just to recap from some of our discussion of ethics with respect to misleading practices, as visualization developers, we should be thinking about how do we present our data as faithfully, factually, and honestly as possible. In other words, we want to build representations that help people understand their data. We do not want to create representations that lead people down the wrong path or cause them to draw incorrect conclusions. So, how do we do this? Well, we've talked about some basic rules of thumb, and we've now explored how we can use tasks and perception and data abstraction and work with users to design effective solutions. But there are additional questions that we should be asking ourselves when we create visualizations that may not be as simply put as which visualization is going to let me see an average. The first of these is, how do we deal with data semantics? We've seen semantics before in the context of things like color choice, where the semantics of the data can actually lead to more intuitive conclusions and more intuitive design outcomes. But sometimes semantics muddies the waters. For example, if we're showing data about human tragedy, is it appropriate to use abstract and clinically detached marks? For example, is it acceptable to show the same design for the percentage of cats and dogs adopted as it is to show for people injured or killed in a particular natural disaster? There are cases where being abstract can be bad. It can allow us to forget about the fact that there are faces and there are people and there's meaning behind the data. But if we instead turn to more rhetorical practices where we're using things like icons or colors to remind people that this is data about human tragedy, the resulting affective impact, things like shifting the emotions or biasing people towards less risky decisions, can be problematic if, for example, we are a clinician who is reasoning about a treatment for a patient. Integrating this kind of emotion might impair a clinician's judgment and cause undesirable outcomes. So it's important to remember that visualizations inherently impact people, and that the semantics of the data and the context in which that data is used need to be carefully considered when you consider the degree of abstraction and any sort of rhetorical principles or practices that might be integrated into your representations. Data also tends to be treated with an air of authority. We tend to see data as factual and not something to be questioned. However, as we've seen a lot in modern media, data isn't always what it's cracked up to be. Data has bias. Data reflects a contextualized sample that is a contextualized sample that can cause us to really make incorrect conclusions about the state of the world. Data has uncertainty. Data has bias, data has context, data has all of these messy things that make it inherently imperfect. And sometimes we want to slow people down and force them to think through their data. One of the ways that we can do this is through something called design friction. Well, by introducing design friction, what we can do is we can actually cause people to slow down and more critically interrogate the patterns and conclusions they draw from their data. For example, if I have a set of data points here and I see, generally speaking, that I have this nice linear upward trend, I also might lose sight of this outlier down here in red. So if I am able to visually discount this outlier, which seems to be an unusual point, maybe one that doesn't actually reflect a good sample, I might predict that the next point in this data set would be somewhere up here. And so I might visually estimate this trend, and based on visually fitting a line through these points, I get a sense of where the next point is likely to be robust to this outlier. However, if I actually compute the line of fit for this data, what I might see is that outlier is going to count just as much as data in the mean of the distribution. And so this is going to pull our perceived line of fit down. And if I show the line of fit, it will cause people to think that the next point in the series is right here, significantly lower than that predicted by I alone. This is an idea called implicit uncertainty. Sometimes the best way to show uncertainty is not to show anything at all, but rather to slow people down and have them do the process of inferring and predicting what should happen in their data themselves. On a similar line, we can also think about whether or not visualization mirages might arise in our data. Visualization mirages are false patterns that arise as a function of the way we preprocess or wrangle our data, or as the way we render our visualizations. And this preprocessing or rendering can introduce false artifacts or even change the structure of the data. We have some examples of this here. For example, if I show the sum of values in two categories A and B, even though those two categories may have the same overall average, B looks to be much, much larger than A, in part possibly because it has more samples, in part possibly because there's missing or corrupted data in A. So by just changing from sum of values to average of values, we see two very different relationships between A and B. We can also see this in this radar plot here in the middle where we have our axes in different order. On the left, having our axes arrayed one way, we can see a skew in the data, that the values are much larger on these three axes on the right than they are on the axes on the left. However, if I rearrange those axes, these skews instead look like outlier points, where we have this star shape that emerges that emphasizes the contrast between subsequent pairs of axes. And finally, you'll recognize this set of diagrams from our last lecture. We can even get this when we start to aggregate our data. For example, if I show you a bar chart with error bars, that bar chart and error bars inherently hides the fact that I might have drastically different data distributions and data skews reflected in these overall samples. Here, the overall samples look very, very similar, but if I see the distribution of points in these samples on the right, I can see that they're actually fairly different. So I hope these questions give you things to think about and to look out for in your own design and data. There is a lot more to explore here, and the ideas of how do we do ethical data visualization are constantly in discussion and dialogue. A few sets of readings you'll see here offer interesting alternative and additional perspectives to some of what we've talked about in this lecture, and if it's a space you're interested in, I would strongly encourage you to do additional readings. Otherwise, I hope this lecture at least offers a set of interesting questions and useful practices that you might think about when you're starting to assemble your solutions for your particular problem area.